Hello students, in this class we will discuss about the methods of purification of organic compound. So when an organic compound it is extracted from the natural source, it has to be synthesized in the laboratory because it is essential to purify it. Okay, so there are some common techniques of purification. Number 1 is sublimation. Number 2 is crystallization. Number 3, we will study all these methods, that is sublimation, crystallization, distillation, differential extraction and chromatography. Now how can we check the purity of a compound? So purity of a compound can be checked by melting point and boiling point. That if a compound has perfect, so we know the melting point and boiling point of an organic compound. Now if that whatever we have the substance, if that substance matches with the standard melting point and boiling point, then we can say that it is a pure organic compound. So like that only we can clarify the compound is pure or not. Okay, so various methods are there for purification. First method is sublimation, but let me tell you students that in modern world the new methods for checking the purification, to check the purity of an organic compound, various types of chromatic and spectroscopic techniques are used. Okay, so we will also study about them. So first let me tell you about sublimation. So what is sublimation? So sublimation means that solid substance it is directly changing to vapor, okay, without passing the liquid state. So okay, the purification technique based on the above principle is known as sublimation. So it is to separate sublimable. So in this method what is happening, the sublimable compounds they are separated from non-sublimable impurities. Suppose you have an organic compound, okay, now this organic compound it is sublimable in nature, okay, and it is containing various impurities which are non-sublimable, okay. So by this method, by the process of sublimation, I am separating the non-sublimable impurities from the sublimable organic compound, okay, like that we are getting the pure compound. Okay, now you can say that suppose there is an organic compound where there are sublimable impurities also, then first step, that I am doing if the organic compound is sublimable, I am removing the non-sublimable compound. Now I have to use a different method to remove the sublimable compound, okay, to get the pure compound. Okay, now crystallization, this is the second method. This is most commonly used technique is crystallization, very important for the purification of solid organic compounds. Okay, so for the solid organic compound the most commonly used technique is crystallization, and what it is based on, these lines are very important, that it is based on difference in solubilities of compound and impurities in suitable solution. Okay, the impure compound, so the principle, you can say this is the principle, okay, that is the difference in solubilities of compound and impurities in suitable solvent. Suppose I have an organic compound containing impurity and I have a solvent, okay, now the organic compound will not dissolve in this solvent, but the impurities will dissolve in this solvent. By this method I can separate the impurities from the compound. See, the impure compound is dissolved in a solvent in which it is sparingly soluble at room temperature but appreciably soluble at a high temperature. The solution is concentrated to get a nearly saturated solution. On cooling the solution, pure compound crystallizes out and is removed by filtration. So what is happening, that I am taking a solution which is I am taking a solvent which is nearly saturated. Okay, now the impurities, they are sparingly soluble in room temperature, and on higher temperature they are appreciably soluble. Okay, so what will happen, that when we are taking that, when we are taking solution at a room temperature, what will happen, the or that is the high temperature, we are taking it at a high temperature, the solvent is at high temperature, the impurities will get dissolved in the solvent to form a solution. Okay, now when I am cooling it, what will happen, the pure compound will crystallize out, and I will remove the pure compound by filtration. Now the filtrate is called mother liquor, contains now the filtrate. So by filtration I have removed the compound, the pure organic compound. So the filtrate will contain impurities and small quantity of the compound. So there will be small quantity of the compound. It is not that I am getting the crystal, I am getting the 100% pure compound, not possible. Some quantity of the compound will be there in the filtrate, and the impurities will be there. If the compound is highly soluble in one solvent and very little soluble in another solvent, crystallization can be satisfactorily carried out in a mixture of these solvents. Okay, impurities which impart color to the solution are removed by adsorbing over activated charcoal. This is another important thing. So there are different types of impurities. One type of impurity is non-sublimable from sublimable compound. This is now another type of impurity is that by solubility, that is the impurity is soluble, but the organic compound is not soluble. If the impurity is soluble and the impurity is soluble sparingly at room temperature, appreciably at high temperature. Second type. Now compound, now now see, the pure compound is there, the impurities are there. Now they are saying the pure compound, it is highly soluble in one solvent and very little soluble in another solvent. So by mixture I am taking both the solvent. Okay, so impurities which now this is the third type of impurity, that is which is imparting color to the solution. So how they will remove it? You will remove by adsorb. So you will give activated charcoal in the solution. The activated charcoal will absorb it. Repeated crystallization become necessary for purification of compound containing impurities of comparable solubilities. Okay, when there are solubility, suppose in a solvent, suppose a solvent is taken, okay, now this solvent is containing a compound, impure compound. The impure compound is also soluble, the impurities are also soluble. Then you cannot separate. You need a solvent in which where the impurities have comparable solubilities. Okay, that means impurity will have solubility, or the impurity will have solubility but the compound will not have solubility, the case which we have discussed. But vice versa can also take place, the compound will get soluble but impurity, but this is not the method. Main method is that impurity will get soluble. Okay, now another method is distillation. This important method is used to separate. So see, first one, we are separating we are applying for sublimable organic compound. Second type, we are applying for all organic compound, means normal organic compound, not sublimable ones, but they are solid organic compounds. Crystallization, we are talking for solid organic compound. Third type, distillation. We are used for distillation. What type of method we are using? For what type of organic compound? Volatile liquid from non-volatile impurities, and liquids having sufficient difference in boiling point. Liquids having different boiling point, vaporize at different temperature. This is a very low class concept, class 8-9 concept. This is okay, that there are liquids. Suppose there is a organic compound which is liquid in stage, one is volatile, one is non volatile, okay, or liquids having different boiling point. Okay, so what will happen? So at one particular temperature will come, okay, the vapors are cooled at liquids, so formed or collected separately. So you know what is distillation. There is a distillation chamber. You have studied what is distillation, that at different part. Here one temperature, here one temperature, here one temperature. So whatever the temperature suitable, so chloroform and aniline are easily separated by techniques. This is very important, chloroform and aniline. So the vapors will be cooled separately and the liquids so formed are collected separately. Okay, so at first they will cool it at 334 K, chloroform will get separated, and 457 K it will get separated. Means I am suppose I have taken a mixture of aniline and chloroform. Okay, now I have taken a mixture of aniline and chloroform, so I will give heat. Okay, so what from 1 Kelvin to Kelvin like this. So at 334 Kelvin heat, what will happen? The chloroform will become vapor. Now I will collect this vapor. Okay, now this vapor will be cooled. I have got chloroform. Now it is containing aniline. Suppose both are there. Now it is containing aniline, I don't need to do anything. Suppose it is containing something else more. So again I will heat, and that boiling point is 798 K suppose. Now I will again keep on heating. Now the temperature has got 457 K. Again some vapors will be coming out. We will collect it in another, we will collect again. Now this will be aniline. Now we will keep on heating, and now it has reached 798 K. Okay, or the remaining which is left, it is the solution. So I no more I need to, so 3 got separated. Okay, so this is the concept of distillation. The liquid mixture is taken in a round bottom flask and heated carefully. Okay, so liquid round on boiling, the vapors of lower boiling component, see this I was telling, on boiling the vapors of lower boiling component are formed first. Vapors are condensed by using a condenser, and liquid are collected in a receiver. Okay, now the vapors are formed later and liquid can be collected separately. See, this is the diagram. Here I am taking, this is an RB flask, here is the solution. Now this solution is containing 2 or more organic compound having different boiling point. Okay, now heat is given. So I am taking the example of chloroform and aniline. So this is a mixture of chloroform and aniline. So I will separate them. So when the temperature of that flask is 357 K, that is the boiling point of chloroform, right? Sorry, 334 or 457, 334 K. So at this temperature, when the temperature of this flask is 334 K, it will start heating. So vapors will come out. Okay, so the temperature reading is what? 334 K. Okay, so what will happen? The vapors from here it will go, and from here it will come to this condenser. Here the vapor will get liquefied. The vapor will get liquefied to what? Chloroform. And in the receiver I am getting the chloroform. Okay, now whatever is left over here, that is the aniline. Okay, suppose it is a mixture of chloroform plus aniline, some other X. So X is having 798 K, the boiling point. So I will keep on again heating. So now it is containing aniline and that compound X, whatever may be the compound X. So now the temperature of the flask has gone to 457 K. Okay, and X is having 798 K. So now it has got 457 K. The thermometer reading is now 457 K. So now again vapors are coming out. Okay, again now I have changed the receiver. Okay, you need to change over here. You need to put another receiver. Before only, when from 334, it is taking time to reach from 334 to 457. During this time, or you can stop the burner, stop this, you can stop this setup, you can stop the burner, okay, and you have changed this, okay. Now again we have started heating, now it has reached 457K. Now it is, vapors are coming again from the condenser, the vapors are getting cooled, again getting in the receiver. Now the receiver, the next receiver, second receiver, we get aniline, and whatever is left, it is the compound X. I was teaching you this thing, okay. Now we will learn about fractional distillation, and fractional distillation is been shown over here. First let me read out the fractional distillation, then I will tell you what is the fractional distillation, the diagram, then I will teach you the diagram. Now fractional distillation, if the difference in boiling points of two liquid is not much, okay. Now here there is a question, now there is a huge difference, one is 334K, one is 457K, the difference in boiling point was huge. Now the difference in boiling point is not much, simple distillation cannot be used to separate them, obviously, this is very much obvious. The vapors of such liquids are formed within same temperature range and condense simultaneously. Now suppose we are having a mixture of X plus Y. Now the X, this is having boiling point 337K, okay, and Y is having at 342K. So the temperature difference is not much, okay. So when the temperature will be like 337, for it will not last for seconds also, immediately it will become 342, okay. So when the vapors are coming out, both vapors of both are X and Y will come out, and here it will, both X and Y will get condensed and you will receive both things, so same thing will happen, so no use. So that time the technique of fractional distillation is used. In this technique, vapors of liquid mixture are passed through a fractionating column before condensation. So where we are here before condensation, see here before condensation, it is going through the fractionating column. I was talking about this. The fractionating column is fitted over the mouth of round bottom flask. See here the round bottom flask is there. So before it was directly going. Now there is a fractionating column with packing. Okay. There is a fractionating column. Okay. First the vapors will come and pass through here. Both vapors will come and pass through here. Okay. Then the rest will happen. Now vapors of liquid with higher boiling point condense before vapors of liquid with lower boiling point. Obviously the one whose boiling point is low, 337, it will condense before the vapors of lower boiling, it will the vapor higher boiling point condense before the vapors, okay, opposite I am telling you. Vapor will come out of this first, and 342 the vapors will come out late, no problem. Condensation, which will condense first? The vapor having low boiling point, it will condense first, right, because the temperature is less, and it will condense later because temperature is more, right? Understood? Now here there is this is a very important topic, listen to this very carefully. Now the vapors rising up the fractionating column become richer and more volatile compound. By the time the vapors reach to the top of the fractionating column, they are rich in more volatile compound. Fractionating columns are available in various sizes and designs shown in 12.7. So here they have shown this. Simple packed column, bubble packed column. Different types of fractionating columns are present. See, one type, second type, glass. These are the glass beads. Okay, this is what bubble plate column, and this is simple packed. Okay, now here there is a little catch also. See, they are in various designs, sizes. Now a fractionating column provides many surfaces for heat exchange between ascending vapors and descending condensed liquids. Some of the condensing liquid in the fractionating column obtain heat from ascending vapors and revaporizes. So what they are saying, that a fractionating column here, the vapors with higher boiling point will condense before the vapors of lower boiling point. You have understood this, I have told you. Now the vapors rising up the fractionating column. So the vapor which will rise up the fractionating column here, what will happen to them? What will happen to them? They become richer in more volatile compound. So they are rich in volatile compound. Okay, they are rich in volatile compound. By the time vapor reach to the top of the fractionating column, they are rich in more volatile compound. Okay, now fractionating compounds are available in different shape and sizes. I have understood this also, I have made you understood. Now the fractionating columns provide many surfaces for heat exchange between condensed liquid. Now there are so many surfaces where they can absorb it. Okay, so by obtaining heat while from the ascending vapors, they revaporizes. Now the vapors thus become richer in low boiling component. Now the vapors of low boiling component ascend to the top of the column. On reaching the top of the vapor become pure in low boiling component and pass through condenser, and the pure liquid is collected in the receiver. See, so now the vapor thus become low boiling component. Now the vapors of low boiling component, what they are happening to now the vapors, so becoming they are becoming richer in low boiling component. Okay, now they have reached the top of the column. On top of on reaching the top, the vapor will come out. The vapor will pure low boiling component, pure in low boiling component. The low boiling component means the component, there are two mixture of two liquids, right? One liquid was low boiling, one liquid was high boiling, means one was little lower boiling point. So that one, the one which will condense faster, it has reached the top of the fractionating column. Then they will pass through the condensation and pure liquid. After a series of successive distillations, the remaining liquid in the distillation flask gets enriched in high boiling component. Okay, each successive condensation and vaporization unit is called a theoretical plate. So what will happen, one like this will reach higher up, from there it will go and like this. Okay, but the one which is high boiling point, okay, that will be over here. Okay, so see, there is an oil bath also. This is an oil bath. Okay, so the one with high boiling point, high boiling solution will be remaining, and the one, so this is called theoretical plate. Commercially, columns with hundreds of plates are available. Okay, one of the technological application of fractional distillation is to separate different fractions of crude oil in petroleum industry. Okay, distillation. Now we will understand this topic, distillation under reduced pressure. This method purify leaving high boiling points and those which decompose at or below their boiling point. So by reducing pressure, under reduced pressure, what we can do? See, this method we are discussing, this method, right? This method where we are using, for purifying liquids again. Obviously distillation means purification of liquids. For one is having these liquids have high melting boiling points. As they have high boiling, and not only that, below their boiling point they will decompose. Such liquids are made to boil at a temperature lower than their normal boiling point. By reducing pressure on their surface, a liquid boils at a temperature at which vapor pressure is equal to the external pressure. Now see, so it will decompose, so they have very high boiling point. Okay, and decompose at the boiling point or below the boiling point. So now they are intentionally made to boil at a temperature lower than the boiling point. Okay, they are at a temperature lower than the boiling point. How? By reducing pressure. By reducing pressure, the vapor pressure, okay, liquid boils at a temperature at which it now the why reducing pressure? By reducing pressure, because when will a liquid boil? A liquid will boil when the vapor pressure and the external pressure is same. So to attain this vapor pressure equal to external pressure, they need suppose 100 degree Celsius, okay, but by reducing the pressure, what I am doing, I am making the vapor pressure equal to the